Hi, this is Richard White, and I wanted to show you a real quick example of a select sort algorithm in operation. This is a program that I've written in Python to perform a select sort, along with some colored highlighting that we can use to track what's going on. We don't need to spend too much time on the actual program itself here. These are just some print statements that you'll see in a moment. The main algorithm that does the sorting is down here in main, intro, putting numbers into a list, printing out the original unsorted list, and then down here starting at line 69 is where we actually go through with a nested loop and look for the location of the smallest number. Once we've gone through and done the select sort, and we'll explain how that works and see how that works in just a minute, then we print out the final sorted list down here at the bottom. So let's see how this program actually runs. Just a little bit of an introduction here. You can take a look at that and read that if you want. Pause the video. Otherwise, we're going to be tracking this list of values. So you can see it's an unsorted list of numbers between 0 and 99 inclusive, about 20 of those. And in the first run, what's going to happen is you're going to see we're going to start at the beginning of the list and identify the smallest number that we've found. And so far, just looking at the beginning of the list, 87 is the smallest number. We haven't seen anything smaller. Now we're going to pass through the entire list. We're going to run through this and see if we can find a smaller value. You can see right away we're examining 25, and that is a smaller value than 87. So we're going to remember where that is in the algorithm. And as I run through, you can see that 25 is highlighted now in green as the smallest value. The yellow text is indicating which value I'm currently examining. So I'm going through the list, and you can probably imagine as soon as I hit this 6, it's going to say, well, 6, that's a smaller value than 25. I'm going to remember that location there. So 6 is now our new smallest value, and we'll keep on going. Here's 3, which is now the new smallest value, and we keep on going until we get to the very end. And at that point, after we've passed through, we know the location of the smallest value. We're going to take that smallest value, that 3 there, and move it to the front of the list. And now we're going to begin our check again. We've moved that 3 to the front of the list. Now we're going to start checking all the other numbers. We know that the smallest value that we found in that first pass was that 3. So now we're not going to check there anymore. Now we're going to check starting at the second item in the list. And again, that's in green because it's the first one we found. It's the smallest of all we've seen. But as soon as we pass through this 25, we're going to know that, oh, the 25 value is smaller. So again, that's been highlighted as green in here. And we can just keep on going through. We're highlighting the smallest value location there. Looks like 6 is going to be moved to the front of the list now. Not the very front, but right behind the 3. And there it is. And now we're going to continue running through. And each time we successively run through less and less of the list. You can see that the numbers that remain to be sorted are the red ones, and the ones on the left that are white are the ones that we have already sorted. So pretty quickly we get to the end here. It starts to go very quickly at the end, and then we can see that this is our final sorted list. It's useful to be able to look at that list sequentially in time. So we've been kind of looking at a one-dimensional version of it, but if we look at a two-dimensional version of that sort here, as I scroll up, we can see how that sort proceeded over time. And those values coming across there, the yellows as we're searching, the green lines are the ones that we've identified as the smallest value, and it's actually quite a nice little pattern there as we get towards the end and finish up our sorting algorithm. So that's the select sort algorithm. Hope that helps.